Good morning, my dear students. In my previous video session, we discussed about KVL and KCL, that is Kirchhoff's voltage law and Kirchhoff's current law. Okay, and based on those laws, we discussed some numericals also. And some of my students, they insisted me to solve some more numericals on the same concept, that is KVL and KCL. So that's why I am discussing some more numericals. Okay, this is our second numerical. Look at the numerical very carefully. Using KCL and KVL, determine currents I1, I2 and I3 for the network shown below. Okay, here one network is given, complicated network, and this complicated circuit includes resistors as well as batteries. Okay, therefore, in order to find out current I1, I2 and I3, we are supposed to use Kirchhoff's voltage law and Kirchhoff's current law. Okay, and as we know, KCL, that means Kirchhoff's current law, it tells us that current entering the junction must be equal to current leaving the junction. See here, this is a junction point. At this junction, I1 current is entering, I2 and I3 are leaving the junction. Understand? And this I1 has to be equal to I2 and I3, sum of I2 and I3. I1 must be equal to sum of I2 and I3. This is KCL. And according to KVL, the sum of potential differences, okay, across the loop, okay, if we consider this as a loop means closed, okay, I will name it A, B, C, D, E, F. See here, A, B, C, D, A, it is a loop, okay, and according to KVL, the sum of potential differences or EMFs must be equal to, algebraic sum must be equal to 0, that is the KVL. Okay, so we shall use those KVL and KCL in order to find out I1, I2 and I3. Okay, so for this, first consider this loop, applying KVL. See here, I1, I2, I3, three unknown currents are there, therefore we are supposed to use minimum three equations here. Okay, so applying KVL to loop, this loop A, B, C, D, A, B, C, D, A. Okay, so we shall start from this point. I have already told you, from where you start, at that location only you are supposed to stop. Okay, then and then only it is going to complete one loop. Okay, so we shall start from A and we shall get back to A only. Okay, so we shall begin. Okay, see here, positive 24 volt is there, therefore I will write 24, and see here 2 ohm is there. Okay, and this 2 ohm resistor is experiencing current how much? I1 current. Okay, because D is a junction, C is a junction, between the junction the current is always constant. Between the junction I am speaking. Okay, so D is a junction, C is a junction, and D to C there is no junction point, therefore I1 current will remain as it is. Okay, this is I1. See, direction of current is like this, therefore I have indicated by this way. Okay, so you are walking from this point, A point, you observed plus here, therefore I have written 24 volt, and after that 2 ohm is there and I1 current is against you, therefore you write it as minus 2 I1. Reason is very simple. If you start from a point, okay, while traveling, if the current is against you, you take it as negative. If current is along with you, then take it as positive. Okay, since current is against me, therefore I have taken it as negative. Okay, and you reach B, and B to C, C to, again you are traveling this way. See here, I2 current is flowing from D point, D junction point, therefore C is a junction, between the junction current has to remain constant, therefore here also current is I2. From D to C current is going to be I2. Okay, and you started from A to B, B to C, and again you are supposed to travel from C to D. While traveling C to D, the current is against you, therefore I2, it is taken as negative, therefore it is minus 6 I2. And see here, negative terminal of the battery is observed, therefore it is minus 27. And you reach D to A. Now it is one loop. Okay. Therefore it must be equal to 0. See here, this 2 is the value of resistor and this I1 is current. Resistor multiplied by current gives you what? It is voltage. V is equal to R into I. R is a resistor, I is a current. Okay. This whole equation is including EMF as well as potential difference. Understood? So let us call it as, okay, no problem. I will write one more equation. 2I1 minus 6I2, 27 is there, 24 is there, therefore it is minus 3 is equal to 0. So 2I1 plus 6I2 is equal to minus 3. Let us call it as equation 1. Okay. I have already told you, you are supposed to use minimum 3 equations because 3 unknown quantities are there. Okay. Therefore, I will take one more loop. See here, D, C, F, E, D. This is one loop. Therefore, I will consider one more loop. Applying KVL to the loop. Which loop? D, C, F, E, D. F, E, D. Okay. See, once again you start from this point. Okay. Once again you observe 27 plus 27. Therefore, I will write plus 27. And see here. In this particular case, you were walking against I2. Now you are walking along with I2. Okay. Therefore, it is considered as positive. 6 I2. And you reached C, C to F, F to E. See here, F to E you are traveling, and from D current I3 is coming. Okay. Therefore, D and C are junction point. Between the junction, the current has to remain constant. Therefore, here also current is I3. Here also current I3, 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 I3. Till this point, the current is going to be I3. Okay. And you are traveling this way. Okay. Clockwise you are traveling, and I3 is against you. Therefore, it is considered as minus 4 I3 is equal to 0. So, it is 6 I2 minus 4 I3 is equal to minus 27. Let us call it as equation 2. Okay. And one more equation we are supposed to consider. Okay. For that, I will take this junction point, applying KCL, because I will, if I consider KCL, I will take I1, I2 and I3. My equation will contain both all the 3 equations, the 3 points I1, I2 as well as I3. Therefore, KCL, applying KCL to junction, only 2 junctions are there, junction at D. Okay. Therefore, current entering is I1 must be equal to current leaving the junction, that is I2 plus I3. This is equation number 3. Okay. And what I do is, see here, I1 value I know, I2 and I3. This equation 1 contains I1 and I2. Equation 2 contains I2 and I3. Equation 3 contains I1, I2 and I3. Therefore, I have to convert the equations in such a way that I have to cancel any 2 and I can get 1. Okay, unknown quantity. Okay. What I do is, see here, I1, I2 is there. Therefore, I will convert this I1, I2 to I2, I3, so that I can equate that particular equation with this one. Understood? So, putting 3 in 1. See, 2 I1 value is I2 plus I3 plus 6 I2 is equal to minus 3, and 2 I2 plus 2 I3 plus 6 I2 is equal to minus 3. See here, 2 I2 is there, 6 I2 is there. Therefore, it is 8 I2 plus 2I3 is equal to minus 3. Let us call it as equation 4. You can observe here, equation 2 also contains I2 and I3. Equation 4 also contains I2 and I3. Now I can equate equation 2 and equation 3. Okay. So for that I have to cancel one quantity I am supposed to cancel. Okay, see here, 6 is there, 4 is there, 8 is there, 2 is there. Okay, therefore what I do is this minus 4 and I will make this 2 to 4. Okay, for that what I am supposed to do, equation 4 is multiplied with 2, number 2. Okay, and it is added with equation 2. Okay, equation 4 is multiplied with how much quantity? 2, and it is, this quantity is added with what equation? Which equation? Second equation. Okay, so let us first multiply 2 here. 2 8s are 16 I2 plus 2 2s are 4 I3 is equal to minus 6. Okay, and this equation is added with which equation? Equation 2. Equation 2 is this one, 6 I2 minus 4 I3 is equal to minus 27. See here, plus 4 I3 minus 4 I3 cancels. What remains? 16 I2, 6 I2. It is 22 I2 is equal to, see here, minus 27 minus 6. How much is this? This is minus 33. So 22 I2 is equal to minus 33. I2 is equal to minus 33 divided by 22. 11 3s are 11 2s are. Therefore I2 is equal to minus 1.5 ampere. Now I know the value I2. This I2 value I can substitute in equation 1, putting I2 in equation 1. 2I1 plus 6, I2 is minus 1.5 is equal to minus 3. So 2I1 plus into minus minus 6, it is 9 is equal to minus 3, and I1 is equal to 6 by 2 is equal to 3 ampere. I1 is equal to 3 ampere. Now I know the value I1 as well as I2. I can substitute the values in equation 3, putting I1 and I2 in equation 3. So I1 is 3 ampere is equal to, I2 is how much? It is minus 1.5 plus I3, it is as it is. Therefore I3 is equal to 4.5 ampere. Now I know all the values here, I1, I2 as well as I3. See here, I1 current is how much? I1 current is 3 ampere. 3 ampere. Okay, and I2 is how much? I2 is minus 1.5 ampere. Minus 1.5 ampere. And I3 is how much? It is 4.5 ampere. Okay, so according to junction rule, I1 is how much? I1 is 3 ampere. Okay, and 3 ampere is equal to, I2 is how much? I2 is minus 1.5 plus 4.5, that is 3 ampere. 3 ampere. Current entering the junction is also 3 ampere. Current leaving the junction is also 3 ampere. Okay, so this is how you are supposed to calculate the currents, okay, by using KCL and KVL. This is one complicated circuit in which we are supposed to find out the currents in each branch. Okay, ಒಂದು ಕಾಂಪ್ಲಿಕೇಟೆಡ್ ಸರ್ಕ್ಯೂಟ್ ಐತಿದು. ಈ ಸರ್ಕ್ಯೂಟ್ ಒಳಗಡೆ ಸಾಕಷ್ಟು ರೆಸಿಸ್ಟರ್ಸ್ನು ಅದಾವ, ಬ್ಯಾಟ್ರಿನೂ ಅದಾವ. ಓಕೆ, ಈ ಸರ್ಕ್ಯೂಟ್ ಒಳಗಡೆ ಇರುವಂತಹ ಪ್ರತಿಯೊಂದು ಬ್ರ್ಯಾಂಚಿನ ಕರೆಂಟ್ ಎಷ್ಟಿದೆ ಫೈಂಡ್ ಔಟ್ ಮಾಡಿರಿ ಅಂತ ಹೇಳಿ ನಮ್ಮ ಕ್ವಶನ್ ಒಳಗೆ ಕೊಟ್ಟಿದ್ದಾರೆ. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಏನು ಮಾಡೋಣ, ನೇಮಿಂಗ್ ಮಾಡೋಣ. ಏನಂತ ನೇಮಿಂಗ್ ಮಾಡೋಣ? ಎ ಬಿ ಸಿ ಡಿ ಇ ಈ ರೀತಿ ನೇಮಿಂಗ್ ಮಾಡೋಣ. ಓಕೆ, ಬಟ್ ಸ್ವಲ್ಪ ಸರ್ಕ್ಯೂಟ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ. ಎಲ್ಲೂ ಕರೆಂಟ್ನ ಕೊಟ್ಟಿಲ್ಲ ಅವರು. ಕರೆಂಟ್ ಯಾವ್ಯಾವ ಜಂಕ್ಷನ್ ಒಳಗೆ ಎಷ್ಟೆಷ್ಟು ಫ್ಲೋ ಆಗದೈತಿ ಅಂಥೇಳಿ, ಅಥವಾ ಯಾವ್ಯಾವ ಬ್ರ್ಯಾಂಚ್ ಒಳಗೆ ಎಷ್ಟೆಷ್ಟು ಫ್ಲೋ ಆಗದೈತಿ ಅಂಥೇಳಿ. ಬಟ್ ನಾವು ಇದನ್ನ ಏನು ಮಾಡೋಣ, ನೇಮಿಂಗ್ ಮಾಡೋಣ, ಕರೆಂಟ್ ಎಷ್ಟೆಷ್ಟು ಹೋಗೋದೈತೆ ಅಂಥೇಳಿ. ಇಲ್ಲಿ ನೋಡಿರಿ, ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಬ್ಯಾಟ್ರಿ ಇರೋದ್ರಿಂದ ಈ ಕಡೆ ಕರೆಂಟ್ ಹೋಗ್ದೈತೆ ಅಂತ ಕರೆಯೋಣ. ಎಷ್ಟು ಕರೆಯೋಣ? I1 ಕರೆಂಟ್ ಈಸ್ ಫ್ಲೋಯಿಂಗ್ ದಿಸ್ ವೇ. ಓಕೆ, ಒಂದು ಪಾಯಿಂಟ್ ನೆನ್ಪಿಟ್ಕೊಳ್ರಿ, ಈ ಅನ್ನೋನ್ ಕ್ವಾಂಟಿಟೀಸ್ ಏನದಾವಲ್ಲ ಕರೆಂಟ್ I1, I2, I3, I4 ಅವೆಲ್ಲ ಅನ್ನೋನ್ ಕ್ವಾಂಟಿಟೀಸ್. ಓಕೆ, ಅವು ಕ್ವಾಂಟಿಟೀಸ್ ಎಷ್ಟು ಲೆಸ್ ಇರ್ತಾವಲ್ಲ ಅಷ್ಟು ಚಲೋ. ಓಕೆ, ಎಷ್ಟು ಜಾಸ್ತಿ ಆಗ್ತಾವೆ ಅಷ್ಟು ನಮ್ಮ ಇಕ್ವೇಷನ್ಸು ಜಾಸ್ತಿ ಆಗ್ತಾವೆ. ಇಕ್ವೇಷನ್ಸ್ ಜಾಸ್ತಿ ಆಯಿತು ಅಂದ್ರೆ ಸಾಲ್ವ್ ಮಾಡುವಂಥ ಪ್ರೊಸೆಸ್ಸು ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗ್ತೈತಿ, ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತೈತಿ. ಅದರ ಸಲುವಾಗಿ ನೇಮಿಂಗನ್ನು, ಕರೆಂಟ್ನ ನೇಮಿಂಗ್ ಮಾಡುವಾಗ ಸ್ವಲ್ಪ ಕೇರ್ಫುಲ್ ಇರಬೇಕು. ಆ್ಯಸ್ ಲೆಸ್ ಆ್ಯಸ್ ಪಾಸಿಬಲ್ ನಾವು ನೇಮಿಂಗ್ ಮಾಡಬೇಕು. ಓಕೆ, ಸಿ ಹಿಯರ್ I1 ಕರೆಂಟ್ ಈಸ್ ಫ್ಲೋಯಿಂಗ್ ದಿಸ್ ವೇ. ಇಲ್ಲಿ ಬಂದ ತಕ್ಷಣ ನಾವು ಇಟ್ ಈಸ್ ಜಂಕ್ಷನ್ ಪಾಯಿಂಟ್. ಜಂಕ್ಷನ್ ಪಾಯಿಂಟ್ ಮೇಲೆ ಬಂದ ತಕ್ಷಣ ಕರೆಂಟ್ ಸೇಮ್ ಇರಂಗಿಲ್ಲ, ಕರೆಂಟ್ ಚೇಂಜ್ ಆಗಬೇಕು. ಓಕೆ, ಸೊ ಕರೆಂಟ್ ನೋಡ್ರಿ, ಈ ಕಡೆ ಕರೆಂಟ್ ಹೋಗ್ಬೇಕೀಗ, ಈ ಕಡೆನೂ ಕರೆಂಟ್ ಹೋಗ್ಬೇಕು. ಓಕೆ, ಸಪೋಸ್ ನಾವು ಈ ಕಡೆ I2 ತೊಗೊಂಡು ಈ ಕಡೆ I3 ತೊಗೊಂಡಿವೋ ಅಂದ್ರೆ ನಮ್ಮ ಇಕ್ವೇಷನ್ಸ್ ಮತ್ತು ಜಾಸ್ತಿ ಆಗ್ತಾ ಹೋಗ್ತೈತಿ. ಯಾಕಂದ್ರೆ ಮತ್ತೆ ಮುಂದೆ ನಾವು I4, I5, I6 ತೊಗೋಬೇಕಾಗ್ತೈತಿ. ಓಕೆ, ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಏನು ಮಾಡೋಣ, ಈ ಕಡೆ I2 ಅಂತ ತೊಗೊಂಡ್ಬಿಡೋಣ. ದಿಸ್ ವೇ ಕರೆಂಟ್ ಹೌ ಮಚ್ ಈಸ್ ಗೋಯಿಂಗ್? I2. ಹಂಗಾರೆ ಈ ಕಡೆ ಎಷ್ಟು ಹೋಯಿತು? I1 ಈಸ್ ಎಂಟ್ರಿಂಗ್, I2 ಈಸ್ ಲಿವಿಂಗ್, ದೇರ್ ಫಾರ್ ರಿಮೈನಿಂಗ್ ಕರೆಂಟ್ ಈಸ್ I1 minus I2. Okay, and always remember between the junction current is going to remain constant. For example, A is a junction, B is a junction. A ದಿಂದ B ತನಕ ಕರೆಂಟ್ ಎಷ್ಟು ಇರ್ತೈತಿ? I2 ಇಲ್ಲಿ ತನಕನೂ I2 ನೇ ಇರ್ತೈತಿ. ಅದೇ ರೀತಿ A is a junction, D is a junction. A ಇಂದ D ಹೋಗೋ ತನಕನೂ ಕರೆಂಟ್ ಏನಿರಬೇಕು? ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಬೇಕು. ಎಷ್ಟು ಕರೆಂಟ್ ಐತಪ್ಪ? I1 minus I2, I1 minus I2, I1 minus I2, I1 minus I2. Till this point the current is I1 minus I2. Okay, okay, ಇಲ್ಲಿ ನೋಡ್ರಪ್ಪ, ಇಲ್ಲಿ ತನಕ I2 current is entering. This is I2 current. I2 current is entering the junction B. This is I2 is entering B. And ಇಲ್ಲಿ ನೋಡ್ರಿ, ಬ್ಯಾಟ್ರಿ ಐತೆ, ಮತ್ತೆ ಬ್ಯಾಟ್ರಿ ಇರೋದ್ರಿಂದ ಈ ಕಡೆ ಕರೆಂಟ್ ತೊಗೊಳ್ಳಲ್ಲ. ಕರೆಂಟ್ ಈ ಕಡೆ ಹೊಂಟೈತೆ ಅಂತ ಹೇಳಿ ಎಷ್ಟು ತೊಗೊಳ್ಳೋಣ? I3. ಓಕೆ, I1, I2 ಆಲ್ರೆಡಿ ಚೂಸ್ ಮಾಡಿವ್ ನಾವು. ಓಕೆ, ಇಲ್ಲಿ ಏನು ತೊಗೊಂಡಿವು? I3 ತೊಗೊಂಡಿವು. I3 ಈಸ್ ಆಲ್ಸೋ ಎಂಟ್ರಿಂಗ್ B, I2 ಈಸ್ ಆಲ್ಸೋ ಎಂಟ್ರಿಂಗ್ B. ಓಕೆ, ದೇರ್ ಫಾರ್ ಹೌ ಮಚ್ ಕರೆಂಟ್ ಹ್ಯಾಸ್ ಟು ಫ್ಲೋ ದಿಸ್ ವೇ? I3ನೂ ಎಂಟರ್ ಆಗತೈತಿ, I2ನೂ ಎಂಟರ್ ಆಗತೈತಿ. ಎರಡೂ ಎಂಟರ್ ಆಗಿ ಈ ಕಡೆ ಎಷ್ಟು ಹೋಗ್ಬೇಕಾ? ಸಿಂಪಲ್, I2 plus I3. I2 plus I3 is entering from B to C. ಈಗ ಸಿಗೆ ಬಂತು ನೋಡ್ರಿ, ಸಿಗೆ ಬರೋ ತನಕನೂ ಕರೆಂಟ್ ಎಷ್ಟು ಇರ್ತೈತಿ? I2 plus I3ನೇ ಇರ್ತೈತಿ. ಬಟ್ ಸಿಗೆ ಬಂದ ತಕ್ಷಣ I2 plus I3 ಇರಂಗಿಲ್ಲ. ಯಾಕೆ ಇರಂಗಿಲ್ಲ ಅಂದ್ರೆ C is a junction point. ಜಂಕ್ಷನ್ ಒಳಗಡೆ ಕರೆಂಟ್ ಏನಾಗ್ತೈತಿ? ಮತ್ತೆ ಚೇಂಜ್. ಓಕೆ, ಬಟ್ ರಿಮೆಂಬರ್, A is a junction point, C is a junction point. A ದಿಂದ C ತನಕ ನಡು ಕರೆಂಟ್ ಏನಿರಬೇಕು? ಕಾನ್ಸ್ಟೆಂಟ್ ಇರಬೇಕು. I1 ಕರೆಂಟ್ ಐತಿ, ಹಾಗಾದ್ರೆ ಇಲ್ಲೂ ಕೂಡ ಎಷ್ಟಿದು? ಇಟ್ ಈಸ್ I1. ಕರೆಕ್ಟಾ? ದಿಸ್ ಈಸ್ I1. ಓಕೆ, ಈಗ ನೋಡ್ರಿ, I2 plus I3 ಸಿಗೆ ಎಂಟರ್ ಆಗತ್ತಿತ್ತು. I2 plus I3 ಕರೆಂಟ್ ಈಸ್ ಎಂಟ್ರಿಂಗ್ ಸಿ. ಆ ಸಿ ಅಷ್ಟು ಎಂಟರ್ ಆಗುವಂತಹ ಕರೆಂಟ್ ಒಳಗೆ I1 ಈಸ್ ಲಿವಿಂಗ್ ದ ಜಂಕ್ಷನ್. ಹಂಗಾರೆ ರಿಮೈನಿಂಗ್ ಕರೆಂಟ್ ಎಷ್ಟು? ವೆರಿ ಸಿಂಪಲ್, ಇಟ್ ಈಸ್ I2 ಪ್ಲಸ್ I3 ಮೈನಸ್ I1. ಕರೆಕ್ಟಾ? ನೋಡ್ರಿ, ಸಿ ಇಂದ ಡಿ ತನಕನೂ ಎಷ್ಟು ಕರೆಂಟ್ ಐತಿ? I2 ಪ್ಲಸ್ I3 ಮೈನಸ್ I1. ಈಗ ನೋಡ್ರಿ, I1 minus I2 is also entering D. I2 plus I3 minus I1 is also entering D. ಹಂಗಾರೆ ಈ ಕಡೆ ಕರೆಂಟ್ ಎಷ್ಟು ಹೋಯ್ತು ನೋಡ್ರಿ. ಒನ್ಸ್ ಅಗೇನ್ ಆ್ಯಡ್ ಮಾಡಬೇಕು ಇವೆರಡು. I1 minus I2 plus I2 plus I3 minus I1. So I1 is cancelled, I2 is also cancelled. ಉಳಿತು ಎಷ್ಟು? I3. ಹಂಗಾರೆ ಡಿ ಇಂದ ಹೋಗುವಂತಹ ಕರೆಂಟ್ ಎಷ್ಟು? I3. ಸಿಂಪಲ್. ಇಲ್ಲಿ ನೋಡ್ರಿ, B is a junction point, D is a junction point. Between the junction current has to remain constant. Already ನಾವು I3 ಅಂತ ತಗೊಂಡಿವು, ಹಂಗಾರೆ ಈ ಕಡೆನೂ ಎಷ್ಟು ಎಂಟರ್ ಆಗತೈತಿ? I3. D ಇಂದ B ತನಕ ಕರೆಂಟ್ ಈಸ್ ಹೌ ಮಚ್? ಇಟ್ ಈಸ್ I3. ಮುಗಿತ್ ನೇಮಿಂಗ. ಈಗ ಅನ್ನೋನ್ ಕ್ವಾಂಟಿಟೀಸ್ ಎಷ್ಟು ಅದು? I1 is unknown, I2 is unknown and I3 is unknown. ಓಕೆ, ಸೊ ಇವು ಮೂರು ಕರೆಂಟನ್ನು ನಾವು ಫೈಂಡ್ ಔಟ್ ಮಾಡಬೇಕು. ಓಕೆ, ಫಸ್ಟ್ ಏನು ಮಾಡೋಣ, ಕೆ ವಿ ಎಲ್ನ ಅಪ್ಲೈ ಮಾಡೋಣ. 3 ಅನ್ನೋನ್ ಕ್ವಾಂಟಿಟೀಸ್ ಇರೋದ್ರಿಂದ ಮಿನಿಮಮ್ ನಮಗೆ ಇಕ್ವೇಷನ್ಸ್ ಎಷ್ಟು ಬೇಕು, 3 ಬೇಕು. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಅಪ್ಲೈಯಿಂಗ್ ಕೆ ವಿ ಎಲ್ ಟು ದ ಲೂಪ್ ಇತ್ತು ಎ ಬಿ ಸಿ ಎ. ಎ ಬಿ ಸಿ ಎ, ಎ ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ನೋಡ್ರಿ, I2 current is going along, okay, with us, therefore it is taken as positive. 4 into I2. ಇಲ್ಲಿಗೆ ಬಂದ್ರಿ ಬಿ ಗೆ, ಬಿ ಇಂದ ನೋಡ್ರಿ I2 plus I3 is also along with you. You are moving and clockwise. Current is also flowing along with you, therefore it is taken as positive. Therefore plus 2 into bracket I2 plus I3. ಸಿ ಗೆ ಬಂದ್ರಿ, ಸಿ ಇಂದ ನೆಕ್ಸ್ಟ್ ನೋಡ್ರಿ I1 ಕರೆಂಟ್ ಇದೆ, 1 ಓಮ್ ರೆಸಿಸ್ಟರ್ ಇದೆ, therefore 1 into I1, therefore it is I1. ಇಲ್ಲಿಗೆ ಬಂದ್ರಿ, ಇಲ್ಲಿ ನೋಡ್ರಿ ನೆಗೆಟಿವ್ ಟರ್ಮಿನಲ್ ಐತಿ, ನಿಮಗೆ ಕಾಣಿಸುವಂತಹ ಟರ್ಮಿನಲ್ ಯಾವುದು, ನೆಗೆಟಿವ್, therefore it is taken as -10 is equal to 0. Sum of potential differences and EMFs across the loop must be equal to 0 according to KVL. So 4I2 plus 2I2 plus 2I3 plus I1 is equal to 10. See here, I1 is there, therefore I will write I1. 4I2, 2I2, it is 6I2 plus 2I3 is equal to plus 10. Let us call it as equation 1. Okay. ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ ನಿಮ್ಗೆ ಮಿನಿಮಮ್ ಎಷ್ಟು ಇಕ್ವೇಷನ್ ಆಗಬೇಕು, 3. ಇನ್ನೊಂದು ಲೂಪ್ನ ಚೂಸ್ ಮಾಡೋಣ. ಸಿ ಹಿಯರ್ ಎ ಸಿ ಡಿ ಎ. ಅಪ್ಲೈಯಿಂಗ್ ಕೆ ವಿ ಎಲ್ ಟು ಲೂಪ್, ವಿಚ್ ಲೂಪ್, ಎ ಸಿ ಡಿ ಎ. ಓಕೆ, ಸೊ ಒನ್ಸ್ ಅಗೇನ್ ಇಲ್ಲಿಂದ ಪ್ರಾರಂಭ ಮಾಡೋಣ. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈ ಕಡೆಯಿಂದ ಹೋಗುವಾಗ ನೀವು ಈ ಕಡೆಯಿಂದ ಹೊಂಟಿರಿ, ಹೆಂಗೆ ಹೊಂಟಿರಿ ನೀವು, ಕ್ಲಾಕ್ ವೈಸ್. ಬಟ್ ನಿಮಗೆ ಕರೆಂಟ್ ಅಪೋಸ್ ಐತಿ, ಕರೆಂಟ್ ಅಪೋಸ್ ಇರೋದ್ರಿಂದ ನೀವೇನಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀರಿ, ರೆಸಿಸ್ಟೆನ್ಸ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಕರೆಂಟ್, ಇಟ್ ಈಸ್ -1 I1. ಬಟ್ ಅದಕ್ಕಿಂತಲೂ ಮುಂಚೆ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಬ್ಯಾಟ್ರಿ ಐತಿ, ದೇರ್ಫೋರ್ ಇಟ್ ಈಸ್ 10 ವೋಲ್ಟ್. ಓಕೆ, ಇಲ್ಲಿಗೆ ಬಂದ್ರಿ, ಬಂದ ತಕ್ಷಣ 1 ಓಮ್ ಮಲ್ಟಿಪ್ಲೈಡ್ ಬೈ ಕರೆಂಟ್ gives you what, potential difference, and this current is against you, therefore it is taken as negative, minus I1. ಸಿ ಗೆ ಬಂದ್ರಿ, ಸಿ ಇಂದ ನೋಡ್ರಿ ಈ ಕಡೆ ಹೊಂಟಿರಿ, current is along with you, therefore it is taken as positive, and it is 2 into bracket I2 plus I3 minus I1, resistor multiplied by current. ಡಿ ಗೆ ರೀಚ್ ಆದ್ರಿ, ಡಿ ಇಂದ ಮತ್ತೆ ಈ ಕಡೆ ಹೋಗ್ಬೇಕು ನೀವು, ಯಾಕಂದ್ರೆ ಯು ಆರ್ ಸಪೋಸ್ ಟು ರೀಚ್ ಅಟ್ ಎ, ಬಿಕಾಸ್ ಯು ಹ್ಯಾವ್ ಸ್ಟಾರ್ಟೆಡ್ ಅಟ್ ಎ. ಓಕೆ, ದೇರ್ ಫೋರ್ ಹಿಂಗೆ ಹೋಗುವಾಗ ನೋಡ್ರಿ, ಕರೆಂಟ್ ಈಸ್ ಅಲಾಂಗ್ ವಿತ್, ಕರೆಂಟ್ ಈಸ್ ಅಗೇನ್ಸ್ಟ್ ಯು, ಕರೆಂಟ್ ಈ ಕಡೆ ಬರೋದೈತಿ, ನೀವು ಈ ಕಡೆ ಹೊಂಟಿರಿ, ಹಂಗಂತಾರೆ ಏನಂತ ತೋತಿರೋದನ್ನ ನೆಗೆಟಿವ್ ಅಂತ ತೋಳ್ತೀರಿ. ನೆಗೆಟಿವ್ 4 is the resistor and current is how much, I1 minus I2 is equal to 0. Okay, so solve ಮಾಡೋಣ ಇದನ್ನ. I1 plus 2I2 plus 2I3 minus 2I2 2I3 minus 2I1 minus 4I1 minus into minus plus 4I2 is equal to 0. ನೋಡ್ರಿ, minus I1 minus 2I1 minus 4I1, 4 2 6 6 plus 1 7, so it is minus 7I1, 2I2 4I2, it is 6I2, 6I2, 2I3 2I3, 10 ಈ ಕಡೆ ಬಂತು ಅಂದ್ರೆ minus 10, so 7I1 minus 6I2 minus 2I3 is equal to plus 10. Let us call it as equation 2. Okay, ಇಲ್ಲಿ ನೋಡ್ರಿ, KCL ನ ಅಪ್ಲೈ ಮಾಡ್ಬೋದಿತ್ತು, ಕಿರ್ಚಾಫ್ಸ್ ಜಂಕ್ಷನ್ ಲಾ ಅಪ್ಲೈ ಮಾಡ್ಬೋದಿತ್ತು, ಬಟ್ ಎಲ್ಲೂ ಅಪ್ಲೈ ಮಾಡಕ್ಕೆ ಅವಕಾಶ ಇಲ್ಲ. ಯಾಕಿಲ್ಲ ಅಂತಂದ್ರೆ ಒಂದೇ ಜಂಕ್ಷನ್ ಪಾಯಿಂಟ್ 3 ಕರೆಂಟ್ ಅವೈಲೇಬಲ್ ಇಲ್ಲ. ಅದಕ್ಕೋಸ್ಕರ ನಾವು ಇನ್ನೊಂದು ಲೂಪನ್ನು ಚೂಸ್ ಮಾಡೋಣ. ಯಾವ ಲೂಪ್ ಚೂಸ್ ಮಾಡೋಣ, ಬಿ ಇ ಡಿ ಬಿ. ನಾನು ಆಲ್ರೆಡಿ ಹೇಳಿದ್ದೀನಿ ನಿಮಗೆ ಮಿನಿಮಮ್ 3 ಇಕ್ವೇಷನ್ಸ್ ನಿಮಗೆ ಬೇಕೇ ಬೇಕು. ಅಪ್ಲೈಯಿಂಗ್ KVL ಟು ಲೂಪ್. ವಿಚ್ ಲೂಪ್? ಬಿ ಇ ಡಿ ಸಿ ಬಿ. ಕ್ಲಾಕ್ ವೈಸರ್ ನೀವು ಅಪ್ಲೈ ಮಾಡ್ಬೋದು, ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸರ್ ಅಪ್ಲೈ ಮಾಡ್ಬೋದು. ಬಟ್ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ದು ಕ್ಲಾಕ್ ವೈಸ್ ಮಾಡಿದ್ರಿ ಅಂತಾರೆ, ಎಂಡ್ ಆಗೋ ತನಕನೂ ಕ್ಲಾಕ್ ವೈಸ ಮಾಡಿರಿ. ಓಕೆ, ಅಥವಾ ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸ್ ನೀವು ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರಿ ಅಂದ್ರೆ ಮುಗಿಯೋ ತನಕನೂ ಆ್ಯಂಟಿ ಕ್ಲಾಕ್ ವೈಸ ಮಾಡಿರಿ. ಓಕೆ, ಸೊ ಇಲ್ಲಿಂದ ಪ್ರಾರಂಭ ಮಾಡೋಣ. ಸಿ ಹಿಯರ್ ಪಾಸಿಟಿವ್ ಟರ್ಮಿನಲ್ ಆಫ್ ದ ಬ್ಯಾಟ್ರಿ ನಿಮಗೆ ಫಸ್ಟ್ ಬರ್ತೈತಿ, ಅದರ ಸಲುವಾಗಿ ಇಟ್ ಈಸ್ ಟೇಕನ್ ಆಸ್ 5. ಇಲ್ಲಿ ನೋಡ್ರಿ ಕರೆಂಟ್ ಅಗೇನ್ಸ್ಟ್ ಐತಿ ನಿಮ್ಗೆ, ಬಟ್ ರೆಸಿಸ್ಟರ್ ಇಲ್ಲದೆ ಇರೋದ್ರಿಂದ ತಲೆ ಕೆಡಿಸ್ಕೊಳ್ಳೋದು ಬೇಡ. ಡಿಗೆ ಬಂದ್ಬಿಡೋಣ. ಡಿ ಇಂದ ನೋಡ್ರಿ 2 ಓಮ್ ಐತಿ, ಕರೆಂಟ್ I2 ಪ್ಲಸ್ I3 ಮೈನಸ್ I1 ಐತಿ, ಆ್ಯಂಡ್ ಅಗೇನ್ಸ್ಟ್ ಐತಿ, ಅದರ ಸಲುವಾಗಿ ಇಟ್ ಈಸ್ ಟೇಕನ್ ಆಸ್ ನೆಗೆಟಿವ್. 2 I2 ಪ್ಲಸ್ I3 ಮೈನಸ್ I1. ಸಿಗೆ ರೀಚ್ ಆದರೆ ಸಿ ಇಂದ ನೋಡ್ರಿ ಒನ್ಸ್ ಅಗೇನ್ ಕರೆಂಟ್ ಈಸ್ ಅಗೇನ್ಸ್ಟ್ ಯು ಆರ್ ಗೋಯಿಂಗ್ ದಿಸ್ ವೇ ಆ್ಯಂಡ್ ಕರೆಂಟ್ ಈಸ್ ಕಮಿಂಗ್ ದಿಸ್ ವೇ. Therefore, current is taken as negative. 2 multiplied with minus 2 multiplied with I2 plus I3 is equal to 0. So, equate madana idanna 5 minus 2I2 minus 2I3 plus 2I1 minus 2I2 plus into minus minus 2I3 is equal to 0. ಇಲ್ಲಿ ನೋಡ್ರಿ I1, therefore it is 2I1. Minus 2I2 is there, minus 2I2 is there, therefore it is minus 4I2. Minus 2I3, minus 2I3, minus 4I3 is equal to minus 5. Okay, so this is our equation 3. ಸ್ವಲ್ಪ 3 ಇಕ್ವೇಷನ್ಸ್ನ ಅಬ್ಸರ್ವ್ ಮಾಡಿರಿ. ಇಲ್ಲಿಯೂ I1, I2, I3, I1, I2, I3, I1, I2 and I3. All the 3 equations contain I1, I2 and I3. Okay, but equation 1 and 2, 6I2 is there, plus 6I2 is there, minus 2I3 is there, plus 2I3 is there. Therefore, if we add equation 1 and 2, we are going to get the value of I1. Okay, therefore, adding equation 1 and 2. Equation 1 is I1 plus 6I2 plus 2I3 is equal to 10. And equation 2 is 7I1 minus 6I2 minus 2I3 is equal to 10. See here, plus 6I2 minus 6I2 cancels, 2I3 cancels. Therefore, 7 plus 1, 8I1 is equal to 20. And I1 is equal to 20 by 8 is 5 by 2 ampere. We know the value of I1 now. Okay, now equation 1 is multiplied by 2 and it is added with equation 3, because in equation 1 we know 6 is there, 2 is there, 2I3 is there, and here minus 4I3 is there. Okay, if we multiply 2 with this equation, it is going to be 4I3, and 4I3 minus 4I3, if we add, they get cancel each other, and I1 value we know. Okay, therefore now equation 1 is multiplied with 2 and added with equation 3. So equation 1 get 2 na multiply madre, 2I1 plus 2 6 the 12, 12I2 plus 4I3 is equal to 20. And it is added with equation 3. Equation 3 ಏನಿದೆ 2I1 minus 4I2 minus 4I3 is equal to minus 5. So 2I1, 4I1 add ಮಾಡತ್ತೀವಿ. ಆ್ಯಕ್ಚುಲಿ ಇಲ್ಲೂ ಕೂಡ ಆ್ಯಡ್ ಮಾಡಿದ್ಯೋ. 12 4, it is plus 8 I2 minus 4 I3 minus 4 I3 plus 4 I3 minus 4 I3 cancel, 20 minus 5, it is 15. Okay. So 4 into I1 value, it is 5 divided by 2 plus 8 I2 is equal to 15. Okay. So 2 1s are 2 2s are 2 5s are 10. So 10 plus 8 I2 is equal to 50. So 8 I2 is equal to 5 and I2 is equal to 5 divided by 8 ampere. Now we know the value of I1 as well as I2, and putting these two values, putting I1 and I2 in which equation? In equation 1. In equation 1. Equation 1 is I1 is how much? 5 by 2 plus 6. I2 is how much? 5 divided by 8 plus 2 I3 is equal to 10. 5 by 2 plus 2 3s are 2 4s are 3 5s are 15 divided by 4 plus 2 I3 is equal to 10. So it is 4, 10 plus 15, 25 plus 2 I3 is equal to 10 and 2 I3 is equal to 10 minus 25 by 4. So 2 I3 is equal to 40 minus 25 is 15. 15 by 4, or I3 is equal to 15 divided by 8 ampere. See, now we know the value of I1 also, I2 also and I3 also. Okay, but the question is, determine the currents in each branch for the below network. This is the question. It means we should know the current between A and B, the current between A and C, A and D, BC, CD as well as BD. Okay, these currents we are supposed to know, but already we know currents I1, I2 and I3. I will write here I1 is equal to 5 by 2 ampere and I2 is equal to 5 by 8 ampere. I will erase this. Current between A and B. See, A to B current is how much? I2, and I2 value is how much? 5 divided by 8 ampere. Okay, and B to C or A to C. AC current, see, from A to C is how much? I1. I1 value we have already calculated. It is how much? 5 divided by 2 ampere. Okay, and A to D. AD is a branch. It is I1 minus I2. I1 is how much? I1 is 5 by 2 and I2 is how much? 5 by 8. This is equal to 8. 20 minus 5 is 15. 15 by 8 ampere. Okay, and BC. See here, B to C is I2 plus I3. And I2 is how much? It is 5 by 8. And I3 is how much? 15 by 8. So it is 20 divided by 8, or 4 2s are 4 5s are 5 by 2